everyone. I'm Anastasia Fischer, President of U.S. Harbors, and I'm thrilled to be here today speaking with John Englander. John is an oceanographer, a fellow at some of the most high-profile marine science institutions, and one of the world's foremost authors and speakers on sea level rise. And his books, which are really great reads, include the best-selling High Tide on Main Street, and more recently, the Moving to Higher Ground, Rising Sea Level and a Path Forward. He's also a scuba diver with over 5,000 dives under his belt and an intrepid traveler, having been on multiple expeditions to both Greenland and Antarctica in his quest to observe and understand sea level rise firsthand. Welcome, John. It's so great to have you.
Thanks, Anastasia. Great to be with you.
So I want to just jump right in and give some context for this whole discussion, just so that we set the stage for our listeners. And can you give us a high level view of exactly what sea level rise is and explain some of the myths and misconceptions about it?
Sure, that's a multi-part question. So we think sea level is a baseline, and we measure things above sea level or below sea level. Almost all real estate, even up in the mountains, is measured as so many feet above sea level, as if that's, you know, a benchmark, a reference point. Well, reference points aren't supposed to move. You know, it doesn't make much sense to measure something from a moving object. And we got fooled because sea level was relatively stable compared to the tides and the waves and the storm surge and all the other things we think of as changing ocean height. But it turns out that sea level has been fairly stable for 6,000 years, which is most of human civilization. So again, it more or less works. But it's risen 8 inches, 20 centimeters roughly in the last century. And the rates are tripling right now. So we need to look into the future. But to put sea level rise in context, which really surprises people, even though it's been stable for 6,000 years, 20,000 years ago, at the peak of the last ice age, sea level was 400 feet lower, 120 meters, as a new sea level. Means the shoreline was miles seaward. In fact, Long Island Sound wasn't Long Island Sound. Long Island was connected with New England back then. The Great Lakes weren't even formed back then. So we need to get some geologic or geographic or education about the change of the planet, because in addition to being 400 feet lower 20,000 years ago, at the last warm spot in the ice age cycle, as you've heard me say, sea level was 25 feet higher. That's the thing that should really get our attention, because even without adding to greenhouse gases by burning fossil fuels and warming the planet and melting the ice and raising sea level, which is the big story, even without that, nature took sea level to a height 25 feet, over 7 meters above present in the last natural ice age cycle. And that blows people away, and it should. So we need to start thinking about sea level differently. It's not going to change in the next year or 2 or 3 by maybe inches, fine. But by mid-century, 20 or 30 years from now, it's going to be at least a foot higher. And by the end of the century, perhaps 5 or 10 feet higher. We need to wake up to a new reality about sea level, because sea level determines the shoreline. We don't think of that, but we see it with tides, you know, whether it be probably a nominal tide change in your area of southern Maine. But of course, when you get up to Bay of Fundy, it's 27 feet or so, right? Daily. Some places it's minimal, but so tides vary. But we tend to think a 3-foot tide change is a big deal for a boat to cope with, right? Imagine when sea level is a meter higher, 3 feet, and then on top of that, we have tides, and then we have storm surge. It's going to require us to think differently about the waterfront, about the shoreline, about coastal real estate, certainly about harbors and boat docks. And we need to start now designing for the future.
That's like, there's so many things to unpack there. Of course, there's the relationship of sea level rise to history. And of course, people say, oh, you know, well, the climate's been changing for eons. And obviously, you know, as you just pointed out, which most people definitely aren't aware of, the fact that in history that sea levels have been rising and dropping like this. But the point is our shoreline is pretty hardened at this point. We humans have decided we want to live as close to the coast as possible. And we're seeing more and more extreme tides and bigger and more ferocious storms. And the currents are even changing, and erosion. How does this all playing together? I mean, I know you're great at putting all these blocks together.
So one way to think about it is that there's short-term flooding, which can be an extreme high tide following the lunar tide cycle. So a new moon, full moon high tide is going to be higher and lower than a normal high tide. We know that. Many people don't know that there's an 18.6-year tide cycle, sometimes rounded up to called the 19-year tidal epoch. That's following the alignment of the planets and giving us extreme high tides. That's the high water mark when we talk about benchmarks. So we're used to that. That's been observed that that 19-year tidal epoch that sophisticated observers will note actually was noticed 1,000 years ago by Meton of Athens, the Metonic cycle. And it's the basis of the Chinese, Mayan, and Jewish calendars being 5,000 years old, but having a 19-year cycle built into them is talk about sophistication of the ancients. I mean, it's pretty extraordinary that they figured that out. But that's embedded not only in those old calendars, but in this Metonic cycle of 18.6 years. So we see that, and again, the daily tidal height might be 2 or 3 feet in New England, perhaps a little bit more in some places. It's almost zero in Puerto Rico, which is a place I'm working now frequently. So tides change a lot. They can be from 0 to 50 feet twice a day. They're going to change with the planets. They're going to change with this tide cycle. That's tides. Then we have storms. We know storms patterns are changing. In our lifetime, certainly, we're seeing different hurricane patterns. We're seeing heavier rainfall. We're seeing more drought. We're seeing more wildfires. We're seeing lots of effects, many of which attribute back to climate change. So that's storms and storm surge, which we think of most violently in the form of a hurricane. Then there's rain and runoff downhill, depending upon the elevation. So storms, rain, runoff are 3 forms of weather-based flooding. Then there's tides is the 4th, and that's predictable by the tide charts, as you know better than anybody. And people can go to your site, U.S. Harbors, and look for tides in where they're boating so that they can time things properly, or fishermen do the same. So those 4 things, storms, rain, runoff downhill, which multiplies the rainfall, tides, those 4 are temporary flooding, with the tides being predictable, the weather events short-term predictable. But sea level rise is different. It's like a drip filling the bucket. It raises the baseline. And right now, it's, as a global average, it's raising at about 1/4 of an inch a year. Not much, but the rate's accelerating. And like the pandemic, that should get our attention, because it's like interest rates. It's one thing when interest is 2 or 3%. It's another when it's 13%. You can go broke or get rich quickly, at high interest rates because of compounding. Well, it's the same thing with the pandemic death rates, as we've all seen. It doesn't matter how many people were sick 2 months ago. It matters how many people are going to get sick this week and 2 months from now, and it's unpredictable. And the melting of Antarctica and Greenland are a little bit like that. We know they're melting. We just can't predict the rate exactly because there's changing inputs. But back to your question, so there's 3 factors of flooding I call storms, rain, runoff. There's tides, and then there's sea level rise is the 5th. And then there's coastal erosion. And if we think of it all as flooding, but it's hard to dissemble it or break, tear it apart in pieces if we don't think of it as the 5 flood factors: the storms, rain, runoff, tides, and sea level rise, and coastal erosion, which is somewhat related. So those 6 things put property underwater. Now, it may be worse from one place to another because the land may be going up or down. So land subsidence or uplift. Alaska's uplifting and New Orleans is subsiding, and so is Norfolk, and different places have land moving up or down. And that either adds to sea level rise or neutralizes it. And that's another factor on a more localized basis. So a long-winded answer to your question, there's many kinds of flooding, of which sea level rise is a special one because it's incremental. It's like a drip filling the bucket.
I didn't realize, this whole conjunction of localized, what's it doing locally versus what is it doing, globally, the global average. I almost don't even want to talk about the global average anymore, because I feel like for local communities, it doesn't make a lot of sense. It's really about what's happening where you are. And there are different factors. Can you just talk about those? I mean, is it just subsidence and uplift, which are geology,
No,
right?
yeah, no, yes, absolutely right. So, well, let's cover that first and then get to the other examples. So uplift typically happens where in the northern latitudes, the ice sheet retreated last. So whether it be Alaska or Scandinavia, their land is still rebounding from the glaciers receding 10,000 years ago. It's called glacial rebound because of the lack of the miles of ice. So that's why those areas are generally uplifting. Places that are subsiding are because of either sediments compacting or pulling water or petroleum out of the ground and causing the layers to the sediments to compact. And that's whether it's New Orleans or Venice, Italy, or Tokyo, or Jakarta be the extreme example, where because of groundwater pumping, the land subsides. So those are examples. But to your question, besides land uplift or subsiding, which either adds to sea level or subtracts from it at the moment, the other big factor is currents. The ocean currents are changing. And so a place like the Gulf of Maine, for example, where you are, you're seeing above global average increases in water height. And it's happening many other places because ocean currents are changing. And as the currents change, you can think of it as sloshing up on the shoreline, if you will, in the macro sense of as global currents change. Also, with changing wind patterns, we're getting patterns where often on the Atlantic, from the southeastern Atlantic, there's a wind and current pattern forcing up against the eastern United States. And so that's kind of pushing water up, if you will, against the land. Same thing happens in the Pacific when you go from El Nino to La Nina, as the ocean currents change, and they're hard to predict these days, but they're attributed to effects of climate change. Again, you'll see changes of a few inches in the Pacific from different islands. So lots of things going on where we always thought that high tide, and low tide and okay, we look out for storms, but we thought sea level was sea level, and it's just not that simple.
And just to get like the last input on it, the whole thing with the warming water it's something it's like the Petri dish idea, right?
No, thank you. I knew there was something I was forgetting, and that wonderful that you would pick up on it. So sea level basically changes with the amount of ice on land, not floating icebergs. They don't affect sea level when they melt because they're like ice cubes in a glass, as you've seen me demonstrate. But it's ice melting on land is either like pouring more water into our virtual glass. Imagine ice cubes floating here. So pouring more water in, of course, would raise the level of liquid. Adding an ice cube would raise the level of liquid. But once the ice cube's in the glass, like an iceberg, as it melts, it won't affect the level of liquid at all because ice is less dense than water. But as you just alluded to quite correctly, besides ice melting from glaciers on land or glaciers breaking off into a new iceberg, which would add to sea level globally, there's thermal expansion of seawater. As you warm water, it has a very small expansion, but it's enough that in the last century, that's attributed about 4 inches of global sea level rise has come from thermal expansion of seawater. The other 4 inches or so, roughly, I just round things off, has come from the ice on land melting. But that's accelerating right now so quickly that that's going to overcome the thermal expansion of seawater. That will continue, but we're now looking at feet of sea level rise this century. The latest NOAA projection in a paper that came out since we last talked, it was in February, looks at 10 to 12 inches of sea level rise as a global average by mid-century. But then in the second half of century, between 2 to 7 feet. In other words, they're noting the acceleration, which is happening decade by decade now. The rate of ice melting on land, and therefore the rate of global sea level rise, has tripled in 30 years. It's gone from an average of 1.5 millimeters to about 5 millimeters in 30 years. Hard to notice, it's fractions of an inch, but it's the acceleration that should get our attention, like compounding interest.
Yeah, so no matter what you think of the science or climate science at all, the truth is our way of life on the coast needs to be examined, even because it's can be observed. We're seeing it, and we're seeing it flooding. I mean, just the other day I was with the town manager in Booth Bay, and we drove around and looked at some of the places where literally there's going to be no way for communities to get across, get back to the mainland. They're going to be cut off in certain events, and with just a very small incremental difference in the water height. So regardless about whether we care about science, we do need to look out for our communities. And so I'm just curious, like, what is changing in terms of what the dialogue is going on with the scientific community at this point? And what are you seeing changing as a result of that dialogue? The NOAA recent report, I mean, there's been a lot of reports on climate change now, and, you know, the people are sort of willing to accept much more willing to talk about it and listen to it. But I think from my perspective, I want to get down to the nuts and bolts of, like, let's do something about that. So I want to find a bridge there. So what are you seeing?
So it's useful to break climate change into 3 issues because they're all important and there's a little overlap, but they require different reactions. Sustainability to me is, how do we produce our energy without warming the planet, increasing the greenhouse gases by burning fossil fuels and producing carbon dioxide, as we know, which has been proven 150 years ago to have a warming effect, even though it's a clear, colorless gas, carbon dioxide, that is. We have to find a way to produce our energy needs. And I don't have the answer to that, but thousands or tens of thousands of people are working on that, from electric cars to better batteries to solar panels and all that, and wind farms. And the question of whether we use nuclear energy or whether we, develop tar sands. I mean, that's all part of that energy debate, and really important. And that's what's causing the warming. And again, it's highly controversial, and I'll step over that for the moment, but it's important. Because the warmer the planet gets, the more the ice is going to melt. The second issue is resiliency. And that's a popular term these days and means a lot of things. But to me, to be resilient, to be prepared to weather the storm, if you will, not just physically the storm, but could be a heat wave, could be too much rain, too much drought, too much wildfires, to be able to continue operations or to recover after an event is to be resilient. And I think that's a generally accepted definition. That's very different than slowing the warming by getting off fossil fuels. So both are important. How do we produce our energy without warming the planet further? And then 2 is knowing the planet is already 1.1 degrees Celsius, right around 2 degrees Fahrenheit warmer. That heat's in the ocean. That's not going anywhere quick. Even if we stop burning fossil fuels, the heat that's in the ocean will continue to melt the ice for centuries. And that's unavoidable now because of the tremendous energy stored in the ocean. 93% of the excess energy that we're trapping in the atmosphere goes into the sea. And that acts like a hot rock, if you will, or a storage battery for heat. And as I say, the truth is, even if we can solve the energy problem and be more resilient, that the heat that's in the ocean is going to cause the ice sheets above me there, Greenland and Antarctica, the big white spots on the world, the ice on land, it's going to cause them to melt faster and faster and raise sea level and change the shoreline. That's just fact. We don't see it that clearly normally, but it's true. And between Greenland, which holds 25 feet of sea level rise potentially, and Antarctica, which holds 185 feet of potential sea level rise, it's mind-boggling. I can see it in your expression, and it's true. It's 212 feet of sea level rise, And that includes a couple of feet from Alaska and the Alps and the Himalayas and all the other glaciers. But 98% of the ice on land is in Greenland and Antarctica. And even if we only melt 5% of it, that's 10 feet of sea level rise. I mean, it's a mind-blowing number. Imagine 10 feet of sea level rise in Portland or Boston or New York or Hartford, Connecticut, or any New England town, but down the coast, Baltimore, Charleston, Savannah, let alone Miami, Jacksonville, biggest port in Florida. We don't tend to think of it. It's in a delta area, very low. We all think about Miami, poor Miami. Well, there's 10,000 coastal communities that should start thinking about sea level rise in 140 nations that have a coastal ocean boundary. Okay, we've really got to think different. We were fooled by 6,000 years of stable sea level rise or stable sea level. And the good news is we have time to adapt. The bad news is this is going to be really a challenge. It's going to change harbors, your passion, and the work for U.S. harbors. It's going to change harbors. It's going to change every coastline from big cities like Jakarta and New York to rural fishing villages in Thailand and Africa. So it's scary. We can think of it as exciting. And the good thing about sea level rise is we really do have a little bit of time to readjust our thinking and get our act together. But it's going to be a daunting challenge to plan for 5 or 10 feet of sea level rise, 2 or 3 meters.
So when we say 2 or 3 meters, that's like the end of the century, is it? We have, 80 years to be 15 feet above where we are right now. Is that 10 feet above where we are right now?
Something like that. And there is we don't know how warm the planet will be. That gets back to the first issue, the sustainability, how we're going to make our energy. If we use enough nuclear power, which some people like, some people don't. If we burn all the tar sands or all the coal in the ground, that's going to determine the heating rate. We don't know how quickly the ice sheets will melt because we don't know how warm the planet will be because we don't know how we're going to make our energy. But yes, to answer your question, it looks like, based upon the best models, that we're pretty well locked into a foot by mid-century in the next few decades. But then it's somewhere between 5 and 10 feet in the century to follow. And it'll get worse as the planet gets warmer. So we have time to think, but it's a radical challenge because we're a coast. We depend upon the oceans, as you know, again, better than anybody, recreation, fisheries, transportation, moving goods. It's all based upon ports and marinas and harbors and beaches. And they all assumed that sea level was pretty stable, except with the waves and tides and so on. But we now should be put on notice. It won't happen in our lifetime so much, and we'll see it. But for our kids and grandkids and nieces, nephews, and just our legacy, we have to think now about something that's almost unimaginable. Sea level being 5 or 10 feet higher, and it's not going to stop there.
Yeah, and then you add the storm surges and the increased winds to things. And that is what, that's where I get really freaked out when I think about what the wave heights will look like if the water is a foot higher. I mean, that's pretty amazing, right? Because there we're just talking exponential because it's got more water to move and it's going to move it bigger, so.
No, thank you. You're absolutely right. So the short-term flooding from storms, rain, runoff, and tides, which are driven by the planetary positions, of course, of the moon, those are short-term floods. One's cyclical, the tides, the others are weather-driven, but sea level rise is the baseline, and then you add the storms on top of that. Now, what fools us is that a storm wave could be 10 or 15 feet. And it's going to change the beach and the coastline and flood things on the shore all over the world. So we see that dramatic event of a hurricane, for example, and then depending on what the tidal changes, sea level is, as I said, like the drip filling the bucket. We tend not to see it because right now it's 1/4 of an inch a year global average, but that's cumulative. And like the drip filling the bucket or catching the leak in your roof in a bucket, whatever, we realize that overnight it fills up typically. And that becomes a new base level. And that's not going down for thousands of years. I mean, just think of it that for sea level to go down, the opposite has to happen. The planet has to get cold enough that the ice sheets on Greenland and Antarctica expand, which requires a colder environment than we have now. We're now in a super warming environment where melting's happening faster than in human history, and changing. You probably see headlines about ice shelves in West Antarctica and now East Antarctica and the glaciers of Greenland. They're all melting at record rates.
So yeah, let's talk about that recent collapse of the ice shelf. As you mentioned, like, yeah, if the ice cube is like just in there, melt already in the water and it melts, it's not going to really impact anything. But if it's on land and then it goes into the water, that is a bigger effect. I mean,
yeah, no, thanks for helping to clarify that. In fact, and I should have done that. So there's ice sheets on, as we can see here behind me, Greenland and Antarctica. They're huge, bigger than the United States, and they're mile or more high, thick. There's glaciers within the ice sheets that are like slow moving rivers of ice that get to the ocean. And when they break off into new iceberg, that does add to sea level, or meltwater as those glaciers and ice sheets melt. And then there's those ice shelves, which are generally filling bays, and where the ice is maybe 500 feet thick or even more, but it's resting on water. So it acts like an iceberg in that if the ice shelf is on ocean, it's already had its effect, like adding another ice cube to the glass. But the big implication from the ice shelves collapsing, which is in the news more and more over the years, is that as the bays become ice-free, as the ice shelves collapse, they're kind of holding the glaciers back up on land in Greenland and Antarctica. So it's kind of a sophisticated phenomenon, but when an ice shelf disintegrates or melts, it allows the glaciers, it's like taking the stopper out or cork out of a bottle. Where the ice shelf is in a bay, it becomes a bottleneck to hold the ice back up on land. And as the ice shelf disintegrates, and that's happening in Antarctica now and Greenland.
It's so frustrating to think about all this happening, really. But we've got to change our attitude, and we've got to like pull up our boots and start to get on with it. There's a whole configuration of the way we live that we've got to figure out how to adjust to. And I want to move now from like this really kind of more technical aspect of discussing to like the discussion about adaptation. There's plenty of great organizations, federal and state and regional, that are working on modeling and have come up with, risk models that we can all use for our towns to evaluate what's going to happen. That's more in line with the emergency management stuff ultimately. But some of those can also be used to understand how we need to start planning for some adaptation. And I want to get your sense of what's happening. What are you seeing happening in the space of adaptation? And how do you think people should be thinking about that?
Great question. So in a world of unprecedented and somewhat unpredictable sea level rise, which is what we just described, we have to think differently in the coastal communities. It's difficult, but the blunt answer is we've got to think about future generations. We may not see the really bad stuff in our lifetimes, but the idea that we'll just leave this to future generations to figure out is irresponsible, and I think immoral, because we now have the information to realize that sea level will be 10 feet higher. We just can't say how soon. That's a new concept of the planet. And there's lots of things in this world we wish were different. There's illness and, the death of our parents or children at times and things like that are just too terrible to think about. But we're adaptive and we're resilient as people, and we're creative, and we go through tough errors and, new awareness. And obviously not everybody survives well, but as a society, we progress, and we have to have hope and positive thinking. I mean, that's essential to carry on in the ways you just described, worrying about it, getting our kids to school, or taking a family vacation, or building a new house. This is a new vision of the planet. And if we'd been born 200 years ago, we wouldn't even know about the ice ages. So we're learning more, just as we are about medical science and the universe, and how old the universe is, or how old the planet Earth is. We're learning about lots of things. We're learning more about pandemics today. We're learning about battery technologies. We're learning about how to do transportation. We need to learn more about how to build higher, because for the first time in 6,000 years, sea level is really starting a forward march upward. And we should see it as an opportunity. Today in the headlines, there was a story from Korea that they're building the first floating community of thousands of homes in Korea, South Korea, obviously. In the Netherlands, they've been building a few hundred homes that go up during flood periods, and where their utilities go through an umbilical, and the house floats during a short-term flood event of high tide or storms, and then settles back down on the ground. And it has the capacity for 6 or 8 feet of sea level rise in it. So we're going to come up with some clever engineering adaptations. We're going to come up with some new kinds of docks floating. I think there'll be more people living on boats. I think there'll be more people living in RVs. I think there'll be more people building structures like this new Korean community for thousands of residents, where it's a floating village, and yet protected from storm surge, so that it floats, but the waves don't directly. There's a riprap big enough to stop the wave action, but allow them to float with the rising tide. We'll do that. We will innovate. We have no choice. The ocean doesn't care about our problems. As any seafarer, particularly Mainers, know, I mean, you don't argue with the ocean. The ocean will do what the ocean will do. And we're really ignorant and stupid if we think we can ignore the sea's power and trends. The truth is, we have to accommodate the sea. We always have.
That's true. There's just so many more of us living on it. One of the things that I've really noticed in my discussions with all sorts of people on this topic is the amount of crossover dialogue that all of us are going to be having to have about this, responding to this issue. How do we actually address our drinking water infrastructure, and also address our boat launches, or the houses that are right there, or the playgrounds? And they're not the same people dealing with these things. The people that are on the front lines of this often in a lot of places are the public works directors at this point, and those people are starting to have to become advocates for addressing adaptation. And it's really interesting to me how the dialogue is developing. And I'm curious what you're seeing in terms of the players that you're seeing getting involved in these dialogues.
Thanks. So as you say, public works directors will look at flooding issues, but they'll typically look out 10 years at most, maybe 20. For most people, that's long-term planning. We have to get this into thinking 50 or 100 years, or at least 30 years to mid-century. But starting now, changing the building code so that the structures we build or design and build today will have useful lives of the typical 100 years that most buildings and infrastructure is designed for, actually. And even though we finance it for 30 years, like a home mortgage, the useful life of buildings and infrastructure is really important to our society. And once we have this new awareness of rising sea level being unstoppable and accelerating, it's just starting the debate. I mean, again, back to that Korean example, or the Dutch example of building floating houses. It's going to take new training. Our universities aren't teaching this yet. The the idea that sea level rise is unstoppable and that historically 20,000 years ago it was 400 feet lower and 120,000 years ago it was 25 feet higher. Most people don't know that. And just like you, we started talking together a year ago. Once you get that concept in your head, it's as simple as aging. We've got to plan for our retirement, for our old age, frankly, our passing and, next generations. That's part of life. And it may not be the fun part of life, but the truth is, it's part of the responsibility if we care about our loved ones and our legacy. And so I frame this like that. We have to think different. And while we might be tempted to ignore it, once you get this visual in your mind that sea level is 400 feet down and it's been 25 feet higher, it changes you. I know it's happened to you, frankly, since we've been talking. And but 99% of the people in the world, and I'm making up that number, I can't swear it's accurate, but something like 99% of the people in the world don't know that. True. And so when people say, what can I do? My house has been here 100 years and I can't lift this house because it's made of stone or something like that. Okay, well, you're going to have to decide. You're going to sell the house, you're going to live it out, or maybe you can lift it up if you think about it twice, or maybe it's time to relocate inland, or if you're old enough and no kids and you got enough money saved, maybe you don't care, which is all fine. That decide on your situation in life. But being realistic about this is essential. And again, I keep picking on Maine because I know that's where you're based, but you have a global audience. But I love New England and Maine, and you have a very practical attitude about life there, and we can ignore this, but the truth is, it's like most concepts that, really powerful concepts. Once the concept's in your head, you're not going to let go of it. And the simple one that sea level is unstoppable, and although it may only be a foot in the next few decades, it could be 5 or 10 feet in the next century. That's a powerful concept. And when people say to me, John, what can I do? The truth is, the simple thing that everybody can do, and this from my book, and we've talked about this, is you can educate others. I don't care whether you're 6 years old or 96 years old. You can explain this to somebody else. And whether, and you've been very kind to promote my book and even selling signed copies through U.S. Harbors.
Absolutely. Everybody go buy one.
But it's available on Amazon in Audible versions and ebook versions if you want. And there's other books. It's not just my book. But if you learn about this, not just from this great little webinar you're doing, you can educate others. And as people understand this truth, this reality, then we will adapt. But the critical first step is to make sure that enough people in the public understand the facts. And I think we'll all agree, until people were watching this very webinar that we are doing right now, most people listening did not know those facts about historic sea level, that it moved up and down 400 feet. And that the rate of rise is tripling, and that it's unstoppable regardless of what we do with renewable energy. So what everybody listening to this can do, whether you buy my book or not, but just take what you've learned and teach 3 people and ask them to teach 3 people, or whatever the multiplier is. That's huge, because once we accept something, whether it be the truth about a pandemic or any other global problem, disease, but shortage of fresh water supply, and as salt water gets into water tables and saltwater intrusion, or
going
what
to the
threat
moon.
of, yeah, or even what 6 inches of water increase can do to the underground utilities or the wastewater treatment plant. There's one city here in Florida that I cite in my first book. 8 inches of sea level rise will cause them to create a new sewage wastewater treatment plant. Just 8 inches. The whole drainage system, when you were down at the Miami Boat Show recently, you probably saw these canals that you frequently drive over down here. It's all part of draining Florida, draining the swamp that was created 80 years ago to make Florida dry enough to build upon. That whole system of drainage canals is largely gravity driven. As sea level gets higher, It's not going to work. We're going to have to put in $1.25 billion of pumps just in 27 pumping locations in South Florida, just to get the flow of water from the swamp, out into the ocean. Who would have thought of that? Okay.
Yeah.
So it's that kind of complexity, but for young engineers going to school or starting their career, or even existing firms, this is a great opportunity. We have to re-engineer the coastlines of the world, not just the United States and Maine and Florida, 140 nations. The world's going to change. The ocean, the sea is rising, and we really need to rise to the challenge.
I love how you're framing that as an opportunity. And I really think that it's important that everyone, no matter what our age is, sees this as an opportunity. I want to thank you, John, so much. I'm going to put the link, the URL to John's website and his Twitter handle at the end of this, and also some resources where you can buy John's book. And I highly encourage you all to read it. And I can't wait till the next time, John. It's been such a pleasure talking to you again. And I want to thank you for all your time that you've given us to sharing all this information, really helping the planet go to the next stage.
Anastasia, thank you for giving me the opportunity, providing the channel, the vehicle to get the word out there, for being such a good promoter of it. So it's a pleasure to work with you and US Harbors, and I look forward to the next time as well.
Thanks again. Take care.